Alright, sorry for the delays. My name is Matthew Nesbitt. I'm the president and co-founder of Coastal Genomics. My company has teamed up with Hamilton Robotics to port our Ranger technology to the NIMBUS platform. Ranger technology allows for the electrophoresis of DNA for the purposes of size selection, but also for the purposes of generating analytical distribution profiles of DNA samples. This presentation will go into a little bit more about what the new NIMBUS Select is capable of, and we'll also talk about some of the results that can be generated and realized through use of this technology. So the first thing that we'd like to talk about is what are the current protocols for actually conducting high throughput fragment length distribution assessments as well as size selection. Largely, what are used in the labs today for generating electropherograms for DNA samples are capillary systems. And these are very usable solutions that have been commonly adopted. However, there are some limitations. One of them is that resolution of large fragments is a little bit complicated. Some of the capillary systems do not work well with those large fragments. Also, capillaries have a tendency to be easily overloaded, and this requires upfront assay plate tuning in order to make sure that you don't put in too much DNA. Of course, the cost per sample can also be significant for a QC pipeline. We've run into systems that typically cost more than $2 a sample. So these are all some of the considerations for what's out there today. As far as size selection goes, the most commonly used method for high throughput pipelines is to use a feed-based size exclusion. What happens there, though, is that you can only really do this with any discriminatory power for fragments that are less than 1,000 base pairs. So it's a good option for fragments that are within that range. But if you're looking to recover larger constructs for either sequencing or cloning purposes, this is not a great option for you. Also, when you're actually doing size selection for fragment length distributions that are less than 1,000 base pairs, if you have a requirement to recover a tightly sized distribution, you're probably going to experience a high degree of intrinsic losses. Now, this may not always be a problem if you have a lot of material, but if the sample is of questionable quality, then you want to be able to get back as much of your material as possible, and with beads, that's going to be a problem. The other problem with size selection with beads is that you don't actually get to see the DNA. So that's what drives the requirement for actually conducting an analytic before the size selection, and in a lot of cases after the size selection as well. So in order to address these concerns with the existing quality control workflows and library construction workflows, Coastal Genomics teamed up with Hamilton Robotics to port our Ranger technology to the NIMBUS platform. So this is a picture of the system right here. The system is a 96-channel liquid handling robot, and it comes with an enclosure that has filtered panes to block out any light that could interfere with the imaging process that's conducted throughout the size selection or analytic electrophoretic run. I'll talk a little bit now about the actual hardware assemblies that compose Ranger technology. The first part of Ranger technology consists of our electrophoresis pedestals. So the system can accommodate 2 electrophoresis pedestals on the deck and still have room for about 6 positions to be used by the liquid handler. Our pedestals are modular, so they can be put on the deck for a size selection or an analytics run, but they can also be removed, allowing the system to be used just as a 96-channel liquid handler. So this means that it can be used for purposes such as PCR setup, serial dilution, and such. But right here you can see the system is mounted with 2 electrophoresis pedestals. Each electrophoresis pedestal can house up to 4 of our Agarose cassettes, and right here we can see that our 12-channel size selection cassettes are loaded on both electrophoresis pedestals. This means that up to 96 samples can be size selected in a single run. However, the system does not require 96 samples. Anywhere between 1 and 96 can be run in a single run, so that makes it a very flexible and scalable option for a lot of library construction pipelines. The other component of Ranger technology consists of gantry arm mounted assemblies. As you can see here through this slide, we do attach a camera to the gantry arm. This is used to capture images of dye-bound or DNA-bound dye molecules throughout electrophoresis. And what we do to actually cause those dye molecules to coalesce is that we actually expose them to either blue or red light from our illumination stage. The blue light is actually used to excite the primary dye molecule, which binds to all DNA within the sample. However, we also use internal markers, which are exclusively labeled with a secondary dye molecule, and this secondary dye molecule is only excited when exposed to red light. So this means that we can effectively identify our markers every time, even though there may be overlap with the sample that would normally flood out the signal from the marker. But it also means that for analytics purposes, we're correctly identifying our marker every time. With some capillary electrophoresis systems that use only a single dye, the software can confuse which is marker and which is sample, and that normally requires the user to go back into the software to reassign the appropriate marker. That problem is avoided with this dual dye system that we've employed here. So that is Ranger technology as it is integrated into the NIMBUS platform. And the NIMBUS Select platform here is basically a 96-channel liquid handler that is capable of conducting either size selection with our size selection cassettes, but it's also capable of conducting analytics in terms of generating fragment length distributions, similar to what a capillary electrophoresis system would do. So as far as the size selection goes, the user sets up the workstation, and then the liquid handler takes over from there. It's going to go ahead and load the samples in the cassettes. It's going to electropherese them, capture images, generate an electropherogram, and then when the appropriate fraction is ready to be extracted, it will reformat that to a destination plate, and an electropherogram that is representative of that size selected material will also be generated for the user. In analytics mode, since we're not conducting size selection and we're just going to get a read on what the fragment length distribution profile looks like, it's only going to go as far as generating that electropherogram. This slide here shows us a little bit about what the user experience is like for setting up the actual deck of the instrument for a size selection run specifically. Coastal Genomics provides reagent kits which consist of our Agarose gel cassettes as well as our DNA loading system, which includes the internal markers. So the user will approach the instrument, unseal the cassettes, and load them onto the electrophoresis pedestals along with the sample plate, a plate for which can act as the destination plate, and our dual dye marker system as well. At that point, the user can interface with the Ranger technology software suite. So this is something that is easy to get up and running with. Alternatively, you can use our CSV file import system, which defines all of the variables for high throughput production facilities. So I have a video here for you, and Tracy, I'll ask for you to go ahead and cue that up right now to show users, to show everyone what the user experience is like with the software.
The user begins by identifying the source plate with either a text name or a barcode, something that can act as an identifier for sample tracking purposes throughout the run. After this, the user will select which wells in the source plate actually house the samples to be size selected, and they'll confirm what kinds of samples those are. So here's where you tell whether it's a next generation sequencing library or you're going after a construct. And then you'll confirm what the volume is of your sample. Coastal Genomics provides cassettes that accommodate either 25 or 45 microliter sample volumes. That's done. The user selects the cassettes that will be used for processing and confirms the agarose formulation in those cassettes. Once that's complete, the user can initiate the run and return to size selected samples in a 2-hour time window.
Thank you, Tracy. So once the user has actually initiated the run through the setup of the software, the instrument then goes ahead and begins the process of conducting the size selection. This slide here is a little animation that shows exactly how it goes about doing that. So the first thing that the NIMBUS workstation does is it engages 12 tips on its 96-channel manifold, and it will then move down to the source plate and aspirate that sample from the first row of that source plate. It then moves over top of our Agarose cassette right here. And the Agarose cassette basically consists of buffer reservoirs at the distal ends of the cassette, and in the middle we have Agarose channels. That Agarose channel has 12 lanes, but in each lane there's a preformed loading well as well as a preformed extraction well. So people that are used to using the clone well system or will be familiar with this kind of side selection method here. It prevents the need to actually cut the agarose gel at all, and you can just actually aspirate it out in 1 times TDE buffer. The system will put the samples in the loading wells, and we have 25 and 45 microliter loading wells, and then electrophoresis is initiated. Again, imaging is conducted in both red light and blue light. The red light allows us to identify the markers that are in each lane, and the blue light allows us to actually see what the sample DNA looks like in terms of fragment length distribution. So multiple images are captured throughout the electrophoretic run and handed to our software processing algorithm. And at midway point through the run, the software identifies where the target is in each sample in the cassette. So there will be 12 targets. They don't all have to be the same. They can vary, but the software decides where those targets are, and it's going to vary the applied voltage on each channel in order to make sure that the arrival of the target fractions in each channel are scheduled so that they come out at the extraction well at the same time. Once that happens, the NIMBUS Select will change its tips, which is not indicated here. But with clean tips, it goes in and aspirates out target fraction from each sample and reformats it to the destination plate. That's the principle behind the side selection ability of the system. For the analytics side of the system, it will simply load the DNA, run out the gel, and capture images and produce an electropherogram for the user. At this point, there's a movie that shows the actual system in operation, and Tracy, I'll ask for you to please cue that up.
So the process starts with an engagement of 12 tips by the workstation. These tips are going to be used to reformat sample from the source plate into our 12-channel cassette for size selection purposes. Tips are available from Hamilton Robotics, and the reagents are available from Coastal Genomics. These tips will be disposed of, and 12 new tips will be used when it comes time to extract the sample from the extraction well downstream. At this point, power is supplied to the cassettes, and multiple images are recorded throughout the electrophoretic process with exposure to red and blue light. This is a movie of the images that are captured by the camera throughout a run. Once the target gets to the extraction well, there will be a well clear up to get rid of fragments that are smaller than the desired target, and then recovery begins. And you'll notice that there is no DNA getting past the extraction well, which is indicative of a high intrinsic recovery yield.
Thank you, Tracy. So as far as the metrics for the system performance go, right now Coastal Genomics has available cassettes for size selection and also cassettes for for groups that are interested only in analytics. Right now we have high-resolution cassettes for that. We will also be releasing low-resolution cassettes in the near future here, which will have a lower per sample cost, but also a lower resolution as well. Size selection cassettes cost $2 per sample. We find that this compares very positively to other automated size selection systems that are available on a per sample cost. We believe it also compares very favorably to manual costs as well. For the size selection itself, up to 96 samples can be processed in about a 2-hour runtime. Fewer samples, of course, can be run, and that would take less time as well. Our accuracy is plus or minus 5% for both the analytics and the size selection. This is a conservative estimate. Normally, we actually perform much better than this, And the resolution at 1,000 base pairs is under 25 base pairs. So now I'm going to move into a bit of a discussion as to what the improvements are when using agarose gels for size selection purposes. There are, of course, benefits beyond just actually being able to see the DNA and do the size selection as well. I'll go over some of those right now. So when we take a look at what the standard is for size selection, high throughput groups, or even medium throughput groups today, magnetic beads have really taken on a big role when it comes to this. And magnetic beads are really a great technology, and they work for a lot of cases. So there's a lot to be said for that. However, there are cases where being able to conduct the size selection of the gel has its advantages. One of those advantages is recovery over a tightly defined size selection window. So this graph here depicts a size selection in green that would be conducted with magnetic beads, where you're trying to exclude things smaller than 300 base pairs and exclude things that are bigger than 600 base pairs. The blue line represents what would be recovered using the NIMBUS Select with Ranger technology. You'll notice that the big difference here is the grade with which the roll-on, as we call it, climbs on for recovery. For bead-based solutions, you normally need to allow for about 100 to 200 base pairs between the fragments that you want to definitely reject and to the point where you want maximum recovery. So if you can think about the area under the graph pertaining as it pertains to actual recovery of DNA, the vertical lines represent X. Horizontal lines, which are indicative of recovery using the NIMBUS Select, represent about a 50% increase in total recovered DNA. So this means that you're going to have improved sensitivity, you're going to be able to salvage samples that maybe aren't the best, and you're also going to be able to be a little bit more selective in terms of the fragment length distributions that you send down for sequencing. Now, a lot of groups would then say, well, I could just widen the size selection window using magnetic beads, and yes, that is true, you can do that. However, if you're going to do this, and there are considerations, for example, by widening out the window, you're going to be recovering a lot of reads that are shorter than your ideal fragment length. You're also going to be recovering a lot of adaptomers as well. On the other hand, if you're going for things that are too big, you get concatamers and large fragments that can also inhibit the efficiency of the sequencing reaction. This table here reflects what some of those results, or what some of those changes can actually do in terms of results. One of the groups that we've collaborated with used an off-kit protocol here, where there was a prescribed bead-based cleanup for a production of a library that was to be run on the MySeq system. This cleanup kit led to a lot of shorter fragments actually being included in the flow cell population. And this meant that basically the full read length was not being taken advantage of. They were having a lot of smaller fragments getting in there and coming to dominate the sequencing reaction, so limited data came out at the other end. When they came to us, we were able to use Ranger technology to efficiently discriminate between fragments that were too small and fragments that were the correct size. We were able to recover a large fraction of the fragments that were larger in size, and that led to an improvement in terms of the data yield. We estimate that the actual data that they got out of the run with Ranger technology versus magnetic beads was an improvement that was about 60% in terms of data yield. And just to drive this home about what the improvements are when you're using gels for a tighter size selection here, this table here shows what some of the values are in terms of intrinsic recovery yields when you're using a bead-based system versus the NIMBUS Select with Ranger technology system. So if you're ever having to do a double-sided size selection where the target range is going to be about between 200 and 300 base pairs, if you're using beads for this, you can expect to recover between 10 and 20% of the actual material that is within that window. However, for fragment length distributions that are of a similar size or even smaller on the Ranger technology system, your yields are closer to between 80 and 90%. So this is great for groups that are dealing with samples that are a large number of samples from a number of different collaborators. Not everybody takes the same care when it comes to shearing or enzymatic digestion time. If you're getting that high recovery yield, then you can just go for that one really large fragment length distribution each time and get enough out of it each time to actually get a reliable sequencing run, which is not always the case if your intrinsic recovery yields are low. This slide here also is another explanation of what the improvements range technology, the improvements the range technology can bring to cloning of the genetic constructs. With another collaborator, we actually used the system to recover a 1.2 kilobase gene synthesis construct. And the same typical process that they used previously to this was to use magnetic beads to do a broad size exclusion. At that point, the size-selected materials from both processes were cloned, transformed into a bacterial vector, and grown up onto two separate plates. The client then actually sequenced the insert from 24 colonies from each plate and found that 22 of the 24 colonies processed with Ranger technology came back with the correct size insert. Whereas with the traditional magnetic bead approach, because they were recovering a lot of the smaller constructs as well and weren't effectively rejecting those, only 7 of the 24 constructs came back as having the correct insert. So you can think about this as meaning the number of colonies you need to sequence to actually find the correct construct is far fewer when you're processing with Ranger technology as opposed to using a magnetic bead-based size exclusion process. And this diagram here kind of shows exactly what the difference is in terms of workflow. The generic magnetic bead process uses a bead-based size selection, and then actually what will happen is that the group that's using the bead-based size selection will conduct a construct analysis, and that's normally done just by running it on a gel. If the material is there, then they will go ahead and they'll just transform that directly. But because there's so many smaller truncation products that make it through the bead-based size selection, the number of true positive colonies are going to be far fewer there than they are when you're using Ranger technology. So much so that we estimate that we're saving roughly half the number of sequencing reactions that would be required in order to have a 95% chance to identify a true positive. So to sum up here, the NIMBUS Select with Ranger technology is definitely a high-capacity, low-cost solution for both size selection and analytics. So if you're currently running gels for size selection, or if you're using capillary electrophoresis systems, this is a good option to think about because not only will it reduce the operating costs, it's also going to improve the actual results that you're getting downstream. The other consideration here is that this solution is one that is ported onto a NIMBUS 96-channel instrument. And as such, it can be used as a 96-channel liquid handler as well. All of the hardware assemblies are modular and can be taken off of the deck in order to allow it to serve the purpose of a general liquid handler. So anyone that's in the market for either a size selection system or capillary electrophoresis system or a liquid handler should consider the NIMBUS Select, as it can conduct all of these operations in one workstation. And that's my presentation today. I want to thank everyone for attending, and I'd be happy to answer any questions that you would like to submit. Again, I'd like to thank everyone for joining us for this conference call and presentation. And if there are any questions, please don't hesitate to reach out to your local Hamilton Robotics rep, or you can contact us by checking out Coastal Genomics' website at www.coastalgenomics.com. Thank you.